Hello students, I hope you are all well. Okay, we will continue with the same chapter. Chapter is ratios and proportions. We have completed first exercise of it. Okay, whatever did we did till the previous video, only that part is important. Now we will move on to the second exercise of this chapter, that is proportions. Okay, so first of all, what is proportions? Proportion is a statement that shows that two ratios are equal. In the ratios part of the chapter, I already told you that what that ratios are unitless quantities. Okay, there is no unit for the ratio. Okay, so we can easily compare any two types of the ratio. In the previous exercise, I also told you that ratios between the quantities having same unit is also only possible. Ratio, you cannot determine ratio between 10 milligram and 10 kilogram. First of all, you have to change both the numbers in the same unit. Both should be either milligrams, both should be either kilograms. After that only you can determine the ratio correctly. Okay, that is not the problem with the proportion because there is no fund of units here. Proportions are not associated with units. Okay, so what is a proportion? It is a statement that shows that two ratios are equal. Okay, so how does it shows that? It shows that the first ratio, A ratio B, is equals to C ratio D, where A comma B comma C and D are any integers. These can be any integers, okay? But they are positive integers. These are positive integers. Okay, now here A, B, this is also the sign of proportion, C ratio D. Okay, here terms B and C are called middle terms, or means. Okay, and terms A and D are called extremes. Okay, and so on. This is the first proportional, this is second proportional, this is third proportion, and this is fourth proportion. Okay, D will be called fourth proportion to A, B and C. C will be called third proportion to A, B and D. B will be called second proportion to A, C and D, and A will be called first proportion to B, C and D. Okay, but we will not go much deeper into that. We will keep in mind the MEANS, means. The term means an extreme. Okay, so what is ratios? What is proportion? If two ratios are equal, then they are called to be in proportion. Okay, a statement in which two ratios are equal, then it is proportion. If we are given that a ratio group of ratios is already in proportion, that means we already know that they are equal. Okay, so we will continue with the exercise with this. I will start with question number 5. Question number 5 is, state which of the following are proportional. We have to tell which of the followings are proportional. Okay, I am taking two parts here. I will leave the rest to you. I'm taking A part first of all. A part is uh, 6:18 and 9:27. So how to determine whether these ratios are equal or not? It is quite simple. First ratio, is 6:18, or we can say it 6 upon 18. We will simplify this. 6 1 is 6, 6 3 is 18, so it is 1:3. Second ratio, is 9:27. Second ratio is 9:27. So what we have to do now, we have to simply find out the ratios, find the simplest term. Okay, so let us do that. Let us simplify it. 9 upon 27 should be equal to 9 ones are 3, 9 9 threes are 27, 1 upon 3. Because the ratios are equal, so ratios are in proportion. Okay. In the same manner, let us try its B part. B part is 3:7.5 proportion sign 2:7. Okay, so let us repeat the process. First ratio, 3 upon 7.5, that is 30 upon 75. Okay, now 15 fives is 75 and 15 twos is 30. Okay, so this is ratio 2 upon 5. Now first ratio is 2 upon 5 and second ratio is 2:7, that is 2 upon 7. As we can see, both the ratios are not equal, since so are not proportional. Ratios are not proportional. Fine. So we will continue. Now we have learned how to determine whether the given set of ratios are proportional or not. Two more parts are remaining. I will leave those parts for your homework. Okay. Now we will move on to next part of the exercise, that is question number 6. Question number 6 is, in question number 6 you are already given that the given set of numbers are in proportion. Then you have to determine the value of the missing variable. Find x in each case okay, in each of the following you have to determine the value of x. So it has 3 parts. I will do 2 parts. The remaining part will be done by you. A part is rupees. Let me do B and C part. B part is 75:15. 75 ratio 15 is equal to x ratio 7. So this will be 75 upon 15 is equals to x upon 7. Okay, so what we do is we simplify first of all. So 15 ones are 15, 15 fives are 75. So we get 5 is equals to x upon 7. Now we transport 7 to the LHS side, left hand side. So on transporting 7 to the LHS side, here x is divided by 7. There 5 will be multiplied with 7. So in this manner you have x is equals to 35. So if x is equals to 35, then this statement is true. Now let us take its C part. C part is x ratio 10 is proportion to 6 ratio 15. Okay, so let us simplify it. X upon 10 is equals to 6 upon 15. Once again simplification, 3 2s are 6, 3 5s are 15. So we have x upon 10 is equals to 2 upon 5. Transporting 10 to the other side, it will be equal to x is equals to 2 upon 5 into 10. 5 2s is 10. In this manner, x will be equal to 4. So when value of x is 4, above statement will be in proportion. Okay. Now question number 7. Question number 7. Okay. Question number 7. Please understand the language carefully. Find the fourth proportion. Find the fourth proportion for each of the following. Find the fourth proportion for each of the following. Okay, that means for the proportion A, B, C ratio D, D is missing. We have to determine the value of D. So this is just like above question, only the instead of x we have to write down D. Okay, we can even write down x, but the position of x is not changing. Like in the previous question, x was changed from places to places, but here the x is the last quantity. Okay, so I am just discussing one example of this question, A part. A part is numbers are 11, 15 and 33. That means we have the ratio 11 is to 15 is proportional to 33 ratio D. Okay, so we have to determine this value of D. So this is 11 upon 15 is equals to 33 upon D. Okay, LHS cannot be simplified any further. It is already in its simplified form. So what we do is transport D to the LHS. So this is 11 upon 15 D. You can solve however you like. Okay, this is cross multiplication simplified. You can solve it as you like. There is no restraint on your solving it. 11 ones are 11, 11 threes are 33. So this is D is equals to 3 into 15. So that way D will be equal to 45. So fourth proportion for the numbers 11, 15 and 33 is 45. Okay, the remaining part, I guess the remaining part you can do by yourself. Okay, now moving on to the second part of the exercise. Second part of the exercise is about continued proportions. Okay, so first of all, let us write down what are continued proportions. For let us write down the definition as it is in the book. Three quantities of same kind okay, same kind means three quantities of same units. When we are discussing about proportions, the unit does not matter, but if we are discussing about continuous proportion, it is given that all these quantities are of same unit, of same kind, are said to be in are said to be in continued proportions are said to be in continued proportion if the ratio of first to second if the ratio of first to second is equal to the ratio of second to third is equal to the ratio of second to third. That is, first quantity is A, second quantity is B, its ratio should be equal to B ratio 3. So there are only three quantities. Okay, all three are positive integers. Here B is called mean proportion, B is called mean proportion, okay, and terms are called third proportional, first proportion and second term. First term B is second term, C is third term, okay, and we also have B square is equals to AC. We also have B square is equals to AC. Now continuing with its questions, we will take question number 8 now. We have completed till question number 7. Before that there were question number 1, 2, 3, 4. Those were option type questions, so I guess you will have to do them by yourself. This is question number 8. Find the third proportion of each of the following. Find the third proportion of each of the following. So in this again I am doing one part, understand it well and try to do the other parts by yourself. A part is 16, 12. Okay, so we have only two terms, we have to determine the third proportion. Third proportion is, let me remind you again, for the ratio A, ratio B is equals to B, ratio C, we have to determine the value of this C. So we will write it as 16 ratio 12 should be equal to 12 ratio C. Okay, writing it in proper order, 16 upon 12 is equals to 12 upon C. By cross multiplying, 16 into C is equals to 12 into 12. Now we have to just solve this expression. C is equals to 12 into 12 upon 16. Now 4 4s are 16, 4 3s are 12, 4 1s are 4, 4 3s are 12. So C is equals to 9. Okay, in this manner you can try other parts of this question as well. Next is question number 9. Question number 9 is find the mean proportional of each of the following. So which value is mean proportional value? The B value. Okay. For the ratio A, B, B, C, we have to determine the values of B, value of B. Okay. So once again, A part is 25, 9. That means A is 25 and C is 9. We will use the direct mean formula. We have B square is equals to A into C. B square is equals to 25 into 9. Okay. B square is equals to 25 into 9. 9 5s are 45, 5, 4, 9 2s are 18. This is 225. So finding the square root of 225, we have already learned about squares and square roots. 3 7s are 21, 3 5s are 15, 3, 25, 5, 5, 5, 1. So value of B should be equal to 1315. 3 into 5, that is 15. Okay. In this manner you can try rest of the questions. Word problems of this exercise we will not be doing. Okay, we will not be doing the word problems of this exercise due to lack of time. So that's all for today. Thank you for your time. Have a nice day.